Let's talk about how one of the biggest internet outages in recent memory was triggered by a tiny, and I mean tiny, database change. And no, this wasn't some massive cyber attack. The real story is so much more fascinating. So, not too long ago, for a solid 3 hours, the internet just felt off. You know? Websites weren't loading, your favorite apps were down, and it really felt like a huge chunk of the web just disappeared. And when I say a huge chunk, I'm not exaggerating. For that window of time, a full 20%. Yeah, 20% of the entire internet was just gone. Think about that, 1/5 of the world's digital infrastructure just blinking out of existence. And I'm willing to bet you ran into this little guy right here. The classic, oh so frustrating, 500 internal server error page. It was suddenly everywhere, no matter where you tried to go. And this wasn't just affecting small, niche websites. We're talking about the heavy hitters. ChatGPT, X, which you probably still call Twitter, and literally thousands of other services that we all use every single day. All of them, down for the count. So naturally, the first question on everybody's mind was the big one. Was this some kind of coordinated cyber attack? Was some bad actor trying to bring the internet to its knees? But the truth? Oh, the truth is way more complicated and honestly, a lot more interesting than a simple attack. This was an internal failure, and the story of how it all went down is just a wild look into how fragile the web can be. Now, to really get what happened, you need to know about a company you might not recognize by name, but whose services you use every single day, CloudFlare. The easiest way to think of them is as the internet's bodyguard. So check this out. Normally, your computer talks directly to a website server, but when a site uses CloudFlare, your request goes to them first. They're like a powerful middleman, checking out all the traffic before it even gets close to its final destination. And why on earth would a website want that? Well, for a ton of good reasons. Cloudflare acts like a shield. It stops massive DDoS attacks, it filters out malicious bots, it speeds up websites by storing copies of them closer to you, and it offers a whole suite of other security tools. For a huge part of the web, they are absolutely essential. Okay, so if Cloudflare is the bodyguard, how did it manage to fail so spectacularly? Well, to figure that out, we have to play detective and follow the clues by tracing the journey of a single click through their system. All right, here's the basic roadmap. When your request hits Cloudflare, first, it gets decrypted so they can look at it. Then, it goes to the core proxy. This is a super important step where all the security checks happen. After that, it looks for a saved copy of the site. And finally, if it needs to, it goes to the website's actual server. The entire outage, all of that chaos we talked about, it can all be traced back to one single point of failure, right here in step 2, the core proxy. And this, my friends, is where we get to the heart of the story. The smoking gun wasn't some crazy bug. It was a well-intentioned security update that had a catastrophic, totally unforeseen side effect. So what was it? What was the tiny change that took down 20% of the internet? To get it, we need to understand one key technical idea. And that idea is a database shard. See, when a database gets absolutely massive, you have to split it into smaller, more manageable pieces to keep it fast. Think of it like taking a giant dictionary and splitting it into 2 volumes, one for A to M, one for N to Z. Same data, just easier to search. The whole thing started with a security update. The goal was to make things more secure by changing some user permissions for how their bot management system talked to those database shards. But it had a side effect no one saw coming. And this slide shows you the problem perfectly. Before the update, the system would ask the database for information and get a nice clean list from one primary source. Simple. But after the permission change, that same exact request started getting back data from multiple sources at once, creating this messy, duplicated pile of data. And this is where the human element comes in. In their own postmortem analysis, Cloudflare said it perfectly. The code was built on a simple assumption that a query would only ever get data from that one single default source. The moment that security change broke that assumption, the entire system started to fall apart. Now, I want you to remember this number, 200. It's the key to the whole collapse. For performance reasons, the system had a hard-coded limit. It was designed to handle a maximum of 200 features or data points in a configuration file. So you can see where this is going, right? That new, messy query, bloated with all the duplicated data, was suddenly generating a configuration file with way more than 200 features. The system was about to hit a wall it was never, ever designed to go past.
And that's what happened. When it tried to load that oversized file, the code hit its limit. This triggered an error the programmers hadn't accounted for, which in the REST programming language is called a system panic. It's basically the program throwing its hands up in the air and saying, "I quit." The whole core proxy crashed, and that's when it started sending that 500 error to everyone.
So once the engineers figured this out and rolled back that one tiny change, the internet snapped back to normal. The next and most important step was to make sure this could never, ever happen again.
CloudFlare got to work right away. They're making it much harder for a bad configuration file to take down the whole system. They're adding more global kill switches so they can turn off broken features faster. And, crucially, they're doing a full deep dive on all their core systems to hunt for other hidden assumptions like this one.
And this whole thing leaves us with a really big question, doesn't it? This massive global crisis was caused by one single incorrect assumption buried deep in the code of a system we all rely on. It just makes you wonder how many other tiny hidden assumptions are holding our incredibly complex digital world together, just waiting for the one wrong change to break everything.